materials, right? You can take an x-ray and see your bones and stuff. Radio waves pass through walls and things, right? And also your cell phones. Engineers, they chose, you know, if you're in a dark room, no light is getting in. If you go in a room, right, and turn off all the lights and close the blinds and everything, no visible light's coming in, but your phone will still work. Well, of course, the engineers chose your phones to operate at a wavelength that goes through the walls and stuff, right? So you can talk if you're in a room and things like that, but light won't go through. And then what is glass? Well, glass is simply a material that visible light can go through, the same way that you know, radio waves will pass through the walls in your house. Your cell phone works in walls in a house, so it's invisible to that. Well, there's some materials that are invisible to light waves, like a window. So let's look at a window. Here's a window, right? So this just happens to be a substance. This is a substance, a window, where visible light passes through this substance, and guess what? Infrared doesn't. That's how a greenhouse works. So a greenhouse, when you have a greenhouse, the visible light will pass through the walls of the greenhouse. It heats things up, but then the infrared can't come out because although this glass, although light easily passes through visible light, infrared doesn't. That's one of the reasons your cars get so hot when they're out in the sun. Because the visible light goes through the windows, it heats up the seats and the dashboard and stuff, and then those radiate infrared, but it can't get out. It doesn't escape, so it's like the greenhouse effect. That's the same thing why Earth, our atmosphere holds temperature, right? Because infrared gets absorbed. It gets absorbed by, you know, water vapor, things like methane, carbon dioxide, right? If we have too much methane and carbon dioxide, it will trap even more infrared, and that's climate change, right? Human-induced climate change. So that's all a window is. It's a substance that visible light goes through. Ta-da! That's why we use it for windows, right? Otherwise we wouldn't use it. We'd use something else, right? So that's a window. Okay. So let me go back over here. Engineers know what they're doing, right? Well, I mean, kind of. They try. There's some things they know, right? Just like anything else. There's some things they know. Okay. So we're back here, right? We're doing this. Okay. Okay, so yeah, so we know that you know, a radio in your house works, right? You turn on a radio, it works. The radio signals come through the walls and your radio works, right? But light doesn't pass through the walls, but it passes through a window. But infrared doesn't pass through a window. That's why greenhouses work. Visible light, so different substances absorb certain wavelengths, and they're invisible, they're transparent to other, you know, that there's opaque. Opaque, invisible light means visible light won't go through it. Well, things are visible and opaque at different wavelengths. Infrared will go through dust, it'll go through a lot of things, but it doesn't like going through glass, right? But it gets absorbed by the atmosphere. Visible light will go through glass, but it won't go through the walls in your house. X-rays go through a lot of things, right? Microwaves are, our atmosphere, a lot of the radio waves just go right through our atmosphere, right? But microwaves get absorbed, certain ones of them. Ultraviolet gets absorbed by ozone. So different substances, and they all react differently to different sorts of wavelengths, right? You all know that already, kind of. I'm just organizing it for you, okay? And that's it. We're not going to talk about colors because that is another whole, well, we'll just talk about it a little bit. We'll talk about it a little bit. Okay, violet, purple, is a really short wavelength. Yeah, I do want to talk about this. Violet, so purple is a really short wavelength, right? It's right next to ultraviolet light, right on the edge, and then we can see. Now red is so these are 10 to the minus 7 meters, the wavelength. So violet is about 3.8, red is about 7.5, and then the other colors are in between. Then on the other side of red, infrared means before red, so the wavelengths there that we cannot see. Those are a longer wavelength, shorter frequency, right? But that's infrared, we can feel that, right? So wavelengths longer than red comprise infrared light, right? The wavelengths get longer as you go this way. In between ultraviolet and infrared is visible light, right? And that's the colors that we're used to: red, orange, yellow, green, blue, indigo, and violet. When I was a kid, the nuns, you know, the nuns had a prism and they shined the sun's light on the wall, right? And we learned Roy G Biv, right? Red, orange, yellow, Roy G, then blue, indigo, violet, Biv, right? I would tell the nuns, there's no color indigo. And they're like, yes, there is, right? They ordered me that there was a color indigo. So I just sat there, but like under my breath, I'm like, there's no indigo. I've never seen anything indigo, right? So, I don't know. But a little bit of history there. Okay, that's it. So we are done. So I'm going to, and then this is it for new material, because it's next week is exams, so you need time to finish up your labs, right? Study this material. I'm going to send out an email that'll detail more about the final exam. It'll be on the chapter since the last test, right? And so that email will be forthcoming. So get those of you that haven't finished all your labs, finish them up. Do a good job. I'm not gonna penalize you for being late, right? We had this virus, this lockdown. I'm not gonna penalize you for being late, but do a good job. I'm still gonna look at the things, right? So that's it, folks. So stay tuned for my email, and be safe out there, right?